You will have more time to work today because I've only got 3 to do. Mika, you should unplug so you can hear me, so you can do more than nothing today. Alright, so here's sample question number 1 that you can write down on that sheet. How far will a car traveling at 80 kilometers an hour go in 25 seconds? Now, one of the things, these ones are a little bit harder today. One of the things you'll have to realize is that sometimes the units will not be matching, I guess you could say. Okay? Like, for example, here, let's read this again. How far? So what are we solving for? Distance, displacement, we're solving for d. Will a car traveling at 80 kilometers an hour, that is our velocity. In fact, is the velocity changing here?
No.
It's not. So that's a constant 80, so we can just say that's the average velocity because that's the one and only velocity there is, right? It's the initial, it's the final, it's the average, it's the velocity.
But it's 288.
In 25 seconds, and that's our time. But you got to look at, exactly, you got to look at the units. Now, one is in kilometers per hour, the other one is in seconds. What's easier to go from to hours to seconds? It doesn't really matter. It doesn't say how far in meters or how far in kilometers, but I think you should all know that in 25 seconds, it's not going very far, is it? Right? So we're probably going to want it measured in meters per second, or meters, the distance, right? So that implies then that you have to take the 80 kilometers an hour, divide by 3.6, right? Because 3.6 is the magic number that I taught you last unit. And we're going to meters per second, so we're going to have to divide. 80 divided by 3.6, which is 22.2. Yeah, we can just round it to 22.2. Right? And what formula has D? What formula has D and V and T in it? Yeah. V equals D over T. Substitute in right up above. Line up your equal signs. Solve for the displacement. Time is 25. And as I've said many times, you need to be able to solve questions like that without even thinking. Times $555 meters. That's how far it's going in 25 seconds. Half a kilometer. I don't know about that. Seems like a stretch to make it fascinating, Dawson.
Yeah, but is it?
No, he said it's fascinating. I mean, it's right, but
Well, not that cool.
yeah. They're not going to make a movie out of it.
This day and age, they'll make a movie out of anything.
Maybe just on YouTube, straight to the video. Okay. Does this one seem higher? A motorcycle rider has an initial velocity of 20. It increased its speed to 35 in 4 seconds. That's not much of a motorbike. Let me just change this. Let me just change this.
That's such a 6-footer athlete.
Mr. Love on his Vespa has an initial velocity of 20 kilometers an hour.
Yeah.
It increases its speed to 35 kilometers an hour in a whole 4 seconds.
Whoa!
What is the acceleration? We are solving for A. Right? Initial velocity of 20. Increases its speed to 35. That's the final velocity. And the time is 4 seconds. What is acceleration? Now, you know that A equals delta V over delta T. We have our time, but what we don't have is we don't have our delta V. So I can't do that one just yet. So I'm going to put that over to the side. Right? That's kind of like the last step. Yeah, you can do it in your head, right? It's going to get harder. You're not going to be able to do it in your head. So you got to know the process. Delta V is Vf minus Vi. The change in the velocity, how much the velocity changes. Yes, just like the David Bowie song, exactly. The final velocity is 35, the initial is 20, giving us a delta V of 15 kilometers per hour. Oh, now just hold on to here for a second. What did I say last example? I just realized 29 kilometers an hour, 4 seconds. Now, do I have to, I'm glad I made this example, I must have been a smart guy a week ago. Do I have to convert 20 to meters per second and the 30 to meters per second, or can I just do the subtraction and then convert?
Do it after.
You can do it.
Bingo.
And then convert.
You can do it after. So while the change of velocity is 15 kilometers an hour, you can also say that it's 15 divided by 3.6. Okay, so you got to convert that kilometers per hour to meters per second, which is 4.17 meters per second. 15 divided by 3.6 is 4.17. And now take that. You take that, exactly. Take that, Fletcher.
How many clutches is that?
Take that number, divide by 4. You get 1.04 meters per second squared. Is that one making sense, Sarah? Making sense? Yeah, we're good?
Pretty straightforward.
Pretty straightforward. Oh. Yeah, this one seems a bit hard. Let's use this one as sort of a practice on your own. You guys try this. How much space do you have?
A lot.
And the backside is blank, right?
Yeah.
Okay, so you got two choices. Either put your answer on the backside and then put the correct answer on the front, or vice versa, right? And if you get it right, then you don't need to. You got lots of space. Okay, you guys give it a try. I'm going to give you like 5 minutes to try. Wait. Okay. A car is traveling at 5 meters per second and increases its speed. So right away we've got an acceleration here, right? It takes 8 seconds. It travels 60 meters in that time. What is its average velocity? We're solving for V bar, right? What is its average velocity? We're solving for V bar. It's traveling at 5 meters per second, so that's the initial velocity. Increases its speed, time of 8 seconds. Travels 60 meters, that's our D value. What is the average velocity? I got D and I got T. That tells me average velocity, does it not? This is, label it, part A. V bar is equal to D over T. So that's going to be 60 divided by 8, which does not go evenly. I think that's going to be 7.5. 7.5 meters per second is our average. What is the final velocity? Oh, I know where this is going. So it starts at 5, and it averages 7.5. 7.5 is in the middle of?
Okay.
So how do we show it in a formula? V bar, remember I showed you to find the average of two things, you add them together and divide by 2. Add them together. This is how you show it. So the average is 7.5, and this is the kind of thing you're going to have to do on occasion. 7.5 is equal to the initial, which was 5, plus VF all divided by 2. Now, solving this is a 2-step. It's kind of a country song. It's 2-step. Funny joke.
Who sings it? It's a dance.
Just about every country person.
The rhythm. Yeah.
Yeah, explain to them later, Ty. It might be a while. Oh, okay.
One step away.
We're going to multiply both sides by 2. Cancel. 2 times 7.5 is 15 is equal to 5 plus VF. And now you take the 5 to the other side by subtracting both sides, a minus 5. Do the same thing both sides. VF is going to be 10, right? Now you might say, but Mr. Bennett, I can just figure it out in my head like this. That's great. What if I change the numbers? So it's not 7.5, it's 7.42, and the average is 8.63. No, so you got to learn the process. It's like saying you're a cook and all you know is craft dinner. The final velocity is 10. What is the acceleration? Okay, here's part C. Stay with me, you guys. Acceleration, what's the formula? Cole, what's the formula? Acceleration?
It's delta V over delta T.
Delta V over delta T. Do I have delta V? Do I have the change in the velocity? You can figure it out. It's pretty simple, right? Again, it's the process that matters. VF minus VI. We're trying to find it. The final is VF, final, 10, minus initial, 5. That you can certainly do in your head. It changes by 5, right? A equals delta V over delta T. We're solving for acceleration. The change is 5, and the time was 8 seconds. And I know what 5 divided by 8 is in my head. 0.63 meters per second squared. Am I right?
Yes, sir.
625, I guess, really.
You're not going now? Yeah, I'm not going.